6. All of my phones down. That's okay. We're going to start with number 6. I'm going to rewrite this so it's a little bit bigger. And I have more space for it. With these, everything is in between two inequality symbols. So that means this is an inequality. So to solve our and inequalities, whatever we do, we have to do to everything at the same time. So we're going to add 4 to the middle and the sides. So we get 18 is less than or equal to 6b, which is less than 36. From there, we can divide 6 to everything. So this would give us 3 is less than or equal to b, which is less than 6. That would be a closed circle at 3, an open circle at 6, with a line that connects them. Oh, do we have any questions on that? Anyone still writing that one down? Yeah. Caleb, you might be able to see better if you move back to your own seat.
It's 12:45.
Okay. Number 8, Caleb. Do the book.
Wow, why is that funny?
You have 2 different inequalities separated by an or. So that means we're going to solve these separately. Whatever you do to one, you are not doing to the other. So let's say we start with this one on the left. I'm going to move my 2x to the left by adding it. And then at the same time, move my 5 to the right by adding it. So that would give us 5x is less than or equal to 0. And then I could divide both sides by 5. So x is less than or equal to 0. On the other side, I like my variables on the left, so I'm going to move 3x to the other side. We have negative 4x, and add 2 to the right. It's less than negative 4. And divide both sides by negative 4. Remember that when you divide by a negative, your sign changes direction. So this will now be x is greater than 1. And you need an or in between your 2 answers. Josh?
Could I do the grafting?
Sure.
Okay, so it would be the frozen circle
At
going from 0, going at left. And the other one, it would be an open circle going from 1 to the right.
correct. any questions on this problem? How we got the answer, got the graph. Before we move on to the next section, do we want to see either of the other two, 5 or 7?
Hydrated. Stay hydrated.
On the next page, this has similar questions on the front and back of this. We're only going to do problems on the front, unless you want to go over problems on the back. So we are going to do 13, 15, and 17, but we're going to start at 15, go to 17, and then come back and do 13. So this is factoring when a equals 1. So for this one, because there's not a number in front of x squared, we're looking for two numbers that multiply to be negative 27, but add to be negative 6. Think about the factors that would multiply to be 27. One of them has to be negative because 27 is negative. Of all of those, which ones would add to be negative 6?
You see these? I'm gonna fill in these. I don't like these.
What are the factors of 27?
1 and 27.
Not 4 and 7. 6. Not 6.
3 and
1. And I think that's it. Okay. Of those factors, one of them have to be negative.
Oh, I got it. Negative 9, 3.
Negative 9, positive 3. If your a value is 1, you can jump straight into your factors. So this would be x minus 9, x plus 3. Before we continue, what questions do we have on that one? Josh?
You said if your factor is 8?
If the number in front of here, that is a. If that is 1, you can go straight into this answer.
Okay, so the 15, what's the 15? That's the answer.
No,
And
that's
that's
the
the
number problem.
Okay.
Problem number, yes.
Okay.
17, same thing. We're looking for two numbers that multiply to be 12, but add to be 7.
4.
4 and 3 would work. Those would both be positive. And again, we have a 1 here, so we can jump straight into our factors. N plus 4 and n plus 3. Do we have any questions on that one? For 13, this one has a number that is not 1 in front of x squared. So it could be a trinomial that where a does not equal 1. But first, let's see, does this have a GCF? Something I can divide out of each of these.
3.
3. So if I divide 3 out of each of these, what's left?
1.
1 x squared.
Is it 9? Give me a second.
You always have to bring
12. 12.
If there is a GCF, you would always bring me out. It is 12x, then 36. So in 15 and 17, we did not have a GCF, so we did not have to bring it out, or the GCF was 1, so bringing it out wouldn't have changed anything. Now the inside looks just like 15 and 17, so we can just focus on the inside where we're looking for two numbers that multiply to be 36, but add to be 12. What two numbers would work?
Can we do the listing of them first?
Mm-hmm.
6 and 9 would be 1.
8.
6, 6 and 9 are two different factors. They don't go together.
Yeah. 6 and 6 would be 36. 9 and
It is 6 and 6, so we don't have to continue. Well, 6 times 6 would give us 36. 6 plus 6 would be 12. So you would bring down your GCF and go straight into your factors. X plus 6, X plus 6. Or, since there are two of them, you could write them in a more simplified way. 3 times X plus 6 squared. Either or, answer is fine. Do we have questions on that one? The GCF?
Yeah.
Okay. What about it?
Why do we?
So we don't. We could do this the same way we're about to do this next section, but because this was in this section, it's assumed that that wouldn't be the ideal way to solve it. Also, if we started that, we'd have to multiply 3 and 108, and we'd end up with some big number. So trying to see if there's something that everything goes into would make this simpler. Do we want to see any others in either this section, 14, 16, or 18, or the same section on the back?
Can we do 14?
14, sure. Which one on the back? In that same section. So we'll do 14, then we'll do 22 on the back, then we'll move on to the next objective. So for 14, this is very similar to 13. Does this have something that each, rephrase. Do these all have something in common?
Yes.
What? 4. So if I divide 4 out of each of these, what would be left?
N squared plus 3 and
Minus 1. So then we're looking for two numbers that multiply to be -4, but add to be 3. Remember that the closer these are, one of your numbers is going to be 1 or -1. So what two numbers would multiply to be -4, but add to be 3? One of them has to be negative.
-1.
-1 and +4.
Yeah.
So your DCF will get brought down, and you can go right into your factors. Thank you. So n plus 4 and minus 1 would be your answer. On the back. In that same section, 22 is similar. Do these have something in common?
Yes.
5. So we could factor out a 5. If we did that, what would be left? X squared minus 2x minus 3. So then we're looking for two numbers that multiply to be -3, but add to be -2. Which numbers will work? 3 and 1. But in this case, the 3 would be negative. So we have 5 times x minus 3, x plus 1. We're going to move back to the front, do a couple problems there, see if you want to do any others. So let's start with 19. This is a trinomial where your a value is not 1. When that happens, first look and see, does this have a GCF? Something they each have in common? No. Besides 1, but that wouldn't change anything. So then we're going to multiply the first number and the last number. And we're looking for two numbers that multiply to be 12 and add to be negative 8. Or in what? Unless it's not 4.
6 and 2 would work.
If they were both negative. So negative 6 and negative 2 would multiply to be 12, positive 12, and add to be negative 8. Then we're going to take those two and replace our negative 8b with those two. So we're going to rewrite this. 3b squared, the first term stays the same. Put these two in place of negative 8 with the variable. So negative 6b minus 2b. And your last term stays the same, plus 4. Now we have 4 terms that we're going to factor by grouping. So split the middle. What do these first two have in common? 3 and b, so we can factor that out. Remember when we factor things out, we're dividing. So if we divide out or factor out a 3b to these two, what would be left? B minus 2. What could we factor out or divide out?
Wait, how'd you get a minus?
Of the last two? This was already negative, and we're dividing it by a positive.
Oh,
Will you use the other one?
Yes, what would we factor out of these two?
2b.
2, because they both don't have a b. But this is negative, so this would be a negative 2. Then if your insides are the same, that would be one of your factors, b minus 2. And everything on the outside would be your second set of factors, 3b minus 2.
Let's say they don't match up. Are they always supposed to match up?
They should always match up. So if they don't, something either you put in or factored out was incorrect. Do we have any other questions on 19? Do these have something in common? Say that again. Which one? 21.
2.
2. We can divide each of them by 2, so if we do that, what's left?
So
7r squared.
55.
Double check that. 55. R minus 8. So then after we factored out that 2, the rest of the process is the same. So we're going to multiply 7 and negative 8. And we're looking for two numbers that multiply to be negative 56, but add to be 55. Say that again. 55. Has to multiply to be 56. You're close.
56 and negative
56 and negative 1. So then we can rewrite this inside as 4 terms. Bring down your GCF. Our first term would stay the same, 7r squared plus 56r minus r minus 8.
Where did you get the minus r?
The minus 1, I just didn't put 1 here. Then we can split the middle. Bring down our GCF. What do these first two have in common?
R.
R and 7. So 7R, if I divide both of those by 7 and R, what is left?
Or is it 6?
8 for the second one, yeah. Or for the first one?
R.
R plus 8. What could we divide out of the last two? -1. And if we divide out -1, what's left?
R. Plus 8.
Plus 8. So what would our final answers be?
R plus 8 and 2.
7R minus 1?
Oh, yes, 7 R.
The 2 would go out the front. Do we have any other questions on that problem? How we got it, the answer, anything like that? Daniel? -56. Oh, here you multiplied 7 and -8 together. Any other questions on that? Were there any others in this section or the same section on the back that we want to see or go over? 20 on this side. Any others? For number 20, does this have a GCF? Or something in common?
No.
No, other than 1, but that wouldn't change anything. So we're going to multiply 3 and -16. -48, I believe. So we're looking for two numbers that multiply to be -48, but add to be -8. Think about your factors of 48. 6 and 8 are factors of 48, but if I added them together, it would not give me 8. 12 and 4, which one would be negative? Oh wait, oh true, well. So then we can start our process. Rewrite 3b squared minus 12b plus 4b minus 16. And then split the middle and start grouping. What do these first two have in common?
3B.
3b. If I factor that out, what's left?
-4. Or no, 4.
For this part, yes. What about this part?
B.
B. And what could we factor out of the second two?
4.
Plus 4. Which would give us
-4. B negative.
b minus 4. And then our final two factors would be what?
B minus 4 is 33 plus 4.
Do we have any other questions? At this time, go ahead and put your cell phones away. Should not be on the desk at all. They can be in your bag if you cannot see them. You can have your notes out. You can use each other. You just cannot ask. You just cannot ask me or Mr. Norfolk, or have your phones or other devices out.